The first thing most people notice about the Great Pyramid of Giza is its size. That's expected. But the real story isn't at the peak. It's in the stone beneath your feet. And that's exactly where we're starting today. What you're about to learn will challenge everything you think you know about ancient technology. Stay with me for a moment, because this isn't just another history lesson. This is a breakdown of real, measurable techniques used thousands of years ago that still raise uncomfortable questions for modern engineering. We're talking about precision work carried out without electricity, without steel, without machines as we define them today, and yet the results hold up under modern scrutiny. This matters beyond curiosity, because hidden inside these ancient methods are survival principles, efficiency under constraint, intelligent use of materials, and systems built to last that apply directly to how you solve problems today. Whether you're building, repairing, organizing, or simply trying to do more with less, the mindset behind these achievements is something you can actually use. By the end of this, you won't just see ancient Egypt differently. You'll start questioning whether modern progress has quietly traded durability and intelligence for speed and convenience. The drill marks in stone reveal a forgotten understanding of materials. Scattered across sites in Giza are granite blocks marked with perfectly circular holes. These aren't rough cuts. They're clean, smooth, and consistent. Evidence of controlled drilling into one of the hardest stones available. Here's where it gets interesting. Traditional explanation points to copper drills. But copper is soft. On the Mohs hardness scale, it sits far below granite. If you tried to cut granite with copper alone, the tool would deform long before the stone gave way. So what actually happened? The Egyptians didn't rely on the copper to cut. They used it as a carrier. The real work was done by quartz sand, an abrasive material harder than the granite itself. Mixed with water into a slurry and fed between the rotating copper tube and the stone, the sand embedded into the copper surface that turned the drill into a constantly renewing cutting edge. This is the first major lesson. They didn't overpower the material. They understood it. Instead of forcing the tool to do everything, they created a system where each component played a role. The copper held shape, the sand did the cutting, and the water managed heat and friction. In practical terms, this is how you solve difficult problems without wasting energy. You stop trying to dominate the system and start working with its natural properties. The measured feed rates suggest efficiency we still struggle to match in the late 19th century. Flinders Petrie examined drill cores recovered from Giza. One particular sample, often referred to as a granite core, contained a spiral groove running along its length. This wasn't decorative. It was the physical record of the drill advancing into the stone. Petrie measured the rate of that advance per rotation and found something unexpected. The drill appeared to move into the granite at a rate that, per revolution, exceeded what many modern systems achieve, even with advanced materials. That doesn't mean the Egyptians had hidden machines. It means they optimized their process to a degree we often overlook. Pressure, angle, motion, and abrasive flow were all carefully balanced. There are competing explanations. Some researchers suggest heavy downward force combined with slight lateral movement created more aggressive cutting. Others propose mechanical assistance or rhythmic motion systems that haven't survived in the archaeological record. But regardless of the exact mechanism, the takeaway is clear. Efficiency didn't come from complexity, it came from control. In survival terms, that's critical. Whether you're cutting wood, shaping metal, or even managing your time, the most effective systems aren't always the most powerful, they're the most refined. Pre-dynastic stone vessels show precision beyond modern expectations. Long before the pyramids, craftsmen were shaping vessels out of materials like diorite and basalt, stones so hard that even modern machinists approach them carefully. These weren't crude containers. They were geometrically consistent, balanced, and in some cases, incredibly thin. Some vessel walls measured just a few millimeters thick, with narrow necks that would have made internal carving extremely difficult. Modern scanning techniques have revealed something even more striking. Certain artifacts display symmetry so precise it approaches the limits of measurement. We're talking about deviations measured in microns. That level of accuracy raises an important question. Was this purely the result of time and patience, or did these craftsmen develop repeatable systems, methods refined through generations that allowed for consistent results? This leads to another survival principle. Skill isn't just about effort. It's about repetition, feedback, and incremental improvement. Over time, a well-trained system, whether it's your hands, your tools, or your workflow, can produce results that seem almost impossible to outsiders. The real power behind the pyramids was organization, not force. There's a persistent myth that the pyramids were built by slaves under brutal conditions. Archaeological evidence tells a different story. Excavations near Giza have uncovered worker settlements complete with housing, food production areas, and medical facilities. These were organized communities, not prison camps. The workforce was largely composed of skilled laborers and seasonal workers. When the Nile River flooded, agricultural activity paused. It created an opportunity to mobilize large numbers of people for state projects. This wasn't random labor. It was structured, supported, and sustained. Workers were fed well, housed properly, and integrated into a broader system with a shared purpose. That's the human engine behind these achievements, not just tools, but coordination. If you're thinking in terms of survival or resilience, this is one of the most important lessons. Individual effort has limits. Organized effort multiplies results. Whether you're managing a team or simply coordinating resources in your own life, structure and shared purpose can achieve what raw effort cannot. The ancient approach prioritized durability over speed. Modern systems often emphasize speed. Faster production, quicker results, immediate output. But speed comes with trade-offs: heat, stress, and long-term degradation. The Egyptian drilling method, by contrast, generated minimal heat. The abrasive action was steady rather than aggressive. That reduced internal stress within the stone, resulting in surfaces that have remained stable for thousands of years. This is a completely different philosophy. Instead of pushing materials to their limits, they worked within those limits to maximize longevity. That principle applies directly to real-world survival. Whether you're building a structure, maintaining tools, or even managing your own physical energy, systems that minimize stress tend to last longer. Short bursts of intensity have their place, but sustainable processes are what endure. What this teaches about solving modern problems with limited resources: strip away the historical context, and what you're left with is a framework that still works today. Understanding your materials means knowing the strengths and limitations of whatever you're working with, whether that's physical resources, time, or even your own capabilities. Optimizing your process means focusing on how the work is done, not just what tools you're using. A well-designed method can outperform a more powerful but poorly managed system. Leveraging organization means recognizing that coordination, whether with other people or within your own workflow, is a force multiplier. Prioritizing durability means making decisions that hold up over time, not just in the moment. These aren't abstract ideas. They're practical strategies that have already been tested over thousands of years. The deeper question is not how they did it, but why we moved away from it. Standing among the structures at Giza, you're not just looking at ancient achievements. You're looking at a different way of thinking. Somewhere along the line, that mindset shifted. Speed replaced patience. Power replaced precision. Complexity replaced understanding. And in many cases, that shift has made systems more fragile, not more resilient. The ancient Egyptians didn't just build monuments. They built processes that worked with their environment, used available materials efficiently, and produced results that have outlasted entire civilizations. That's not just history, that's a benchmark. The final lesson is about what you choose to carry forward. The knowledge behind these techniques wasn't written in manuals. It was passed down through practice, through observation, through generations of refinement. And like any knowledge, it was vulnerable. Time, conflict, and cultural shifts can erase even the most effective systems. What remains are the results. Stone records of a way of thinking that still has relevance today. So the question isn't whether these methods were advanced. The question is whether you're willing to apply the principles behind them. This changed how you see ancient technology, and more importantly, how you approach real-world problem solving. And take that one step further. Subscribe. Share this with someone who takes history seriously, and keep building your understanding of what actually works. Because the past isn't finished teaching. And the people who pay attention are the ones who carry that knowledge forward.